I'll explain to our guests and witnesses that we're expecting a vote at about a series of votes. I wish it were just one, but at about 10:15. The way the votes work is we have about 15 minutes to get over there, but that never is real, so you have 25 minutes to get over there. The theory then being that with 4 witnesses at 5 minutes each, we can actually hear your testimony before we have to run and vote, and then give you all a bit of time to go have a break. But I'd rather go ahead and start. We're waiting for our ranking member on the Republican side to join us. So what we'll do is we'll start. I will forego any opening comments, as hopefully will Mr. Inglis, and I think the chairman, Mr. Gordon, has agreed to do that. So as soon as Mr. Inglis gets here, which we hope will be soon, then we'll proceed, and we'll proceed with alacrity. I think I may just introduce our witnesses, and then before we call the hearing to order, unless there's some procedural reason I can't do that. You have a problem with that? That's very kind of you, since it is now 10:03. I will introduce our witnesses, and there will be additional information about them in the record. David Keith is a Canada Research Chair in Energy and Environment at the University of Calgary. Dr. Philip Rash is a Laboratory Fellow of the Atmospheric Science and Global Change Division and Chief Scientist for Climate Science at Pacific Northwest National Lab. Dr. Klaus Lackner is a Ewing Wurtzel Professor of Geophysics and Chair of the Earth and Environmental Engineering Department at Columbia University. And Dr. Robert Jackson is the Nicholas Chair of Global Environmental Change and a Professor in the Biology Department at Duke University. So we'll hear from them shortly, as soon as we can officially start.
Mr. Chairman, while you are, you want to do that? No, I was just going to rope it up a little bit while we're waiting for Mr. Inglis.
Unless we can start with Mr. Rohrbacher.
I'll be happy to.
Oh, here's Mr. Inglis. Here we go.
There he is. I was just about.
If you still want to rope it up, Mr. Chairman, that's all right.
I'll just real quickly say, as Mr. Inglis gets in place, that I think probably you know that we're having parallel hearings with the Science Technology Committee at the UK. We're looking more at the area of potential research. They're looking at treaties. We hope that we're going to be able to come together later with a joint report, and we have talked with the similar committees in the other EU parliaments, and I think that we will have other countries that will join us. As you know, if we're going to do anything in this area, it needs to be global. And I yield back.
Thank you, Mr. Chairman. With that, we'll call the hearing to order. As I mentioned earlier, I've already introduced our witnesses, and this is a hearing on geoengineering as we deal with the issues of overheating of our planet and acidification of the ocean. This is one option for possibly mitigating the impacts, part of a series of hearings and an effort initiated by our chair, Mr. Gordon. I thank the ranking member for being here. Recognize him if he has any opening remarks.
I don't, Mr. Chairman. I will submit them for the record.
Thank you, and I will submit my opening remarks for the record. With that, we'll proceed. Each witness will have 5 minutes to proceed, and if we have time, we'll follow it with questions. If not, we'll take a break for votes. Dr. Keith, please.
Chairman Baird, members, thank you very much for having me here today. We must make deep cuts in global emissions if we're going to manage the risks of climate change. Emissions reductions are necessary, but they're not necessarily sufficient. This is because even if we halt all emissions instantly today, which is not going to happen, the climate risks they pose would persist for millennia. Also, the climate's response to the amount of CO2 we put in the air is highly uncertain. We could get lucky and see small amounts of climate change, or unlucky. Risk management is the heart of climate policy. So a small risk of catastrophic impacts exists even with today's carbon burden, and that risk grows with each ton of new emissions. So because risk management is central, we must hope for the best while laying plans to navigate the worst. Geoengineering describes 2 distinct concepts. Carbon dioxide removal, CDR, is a set of tools for removing carbon dioxide from the atmosphere, while solar radiation management, SRM, would reduce the Earth's absorption of solar energy, cooling the planet by adding sulfur aerosols to the upper atmosphere or by adding sea salt aerosols to whiten marine clouds. SRM and CDR, forgive me my acronyms, do different things, entirely different things. SRM is cheap and can act quickly to cool the planet, but it introduces novel environmental and security risks, and it can, at best, only partially mask the impacts of CO2 in the air. The low price tag is very attractive, but it raises the risks of unilateral action and of facile cheerleading that promotes exclusive reliance on SRM. In concert with emissions cuts, CDR can reduce the carbon burden in the atmosphere, a kind of global climate remediation. We need this capability. Unless we can remove CO2 from the air faster than nature does, we are consigning the Earth to a warmer future for millennia, or a sustained and risky program of solar radiation management. But carbon removal can only make a difference if we capture carbon by the gigaton. The sheer scale of the carbon challenge means that just like emission cuts, CDR will always be much more expensive and much slower acting than SRM. SRM and CDR, again forgive the acronyms, each provide a means to manage climate risk, but they are wholly distinct with respect to the science and technology required to deploy and test them, with respect to their costs and environmental risks, and respect to the challenges they pose for public policy and governance regulation. Because these technologies have little in common, I suggest that we will have a better chance to craft sensible policy if we separate them almost entirely in the policy process. In the spirit of disclosure, I offer a few comments about my own work. Along with my academic work, I run a startup company, Carbon Engineering, that seeks to develop large-scale industrial technologies for capturing CO2 from the air, a form of CDR. Professor Lackner will say more about this later. I'm thrilled to work on this technology. It has a shot, however small, at providing a tool to manage one of the greatest environmental threats. I'll be happy to answer questions about this and other CDR technologies, but I'll focus my remarks on SRM because I believe that is where there's the most urgent need for government action. Because of the serious concerns raised by the enormous leverage SRM grants us over the global climate, I think it's crucial that the development of these technologies be managed in a way that is as transparent as possible. I therefore do no commercial or proprietary work on SRM. In my written comments, I offer some thoughts about the specific kinds of research that are needed, the funding, the agencies that might be appropriate or might not, the scale of the research program. One thing I'll say here is that we don't want to start too fast. Research programs can be killed by getting too much money too quickly. The idea of deliberately manipulating the Earth's energy balance to offset human-driven climate change strikes many as dangerous hubris. Solar engineering is like chemotherapy. No one wants it. It's far better to avoid carcinogens. But we all want the ability to do chemo and to understand its risks should we find ourselves with dangerous cancer. The primary argument against doing SRM research is fear that it will sap our will to cut emissions. I share this fear. Yet I believe that the risks of not doing research outweigh the risks of doing it. SRM may be the only means to fend off the risk of rapid and high-consequence climate impacts. Furthermore, there are environmental and geopolitical risks posed by the potential of unilateral deployment of SRM by a small or large state acting alone, which can best be managed by developing widely shared knowledge, risk assessment, and norms of governance. I don't mean one big UN-style government system. I just mean some understanding, however it works, of how we manage this thermostat for the planet. It's a healthy sign that a common first response to geoengineering is revulsion. It suggests we've learned something from past instances of techno-optimism and subsequent failures. But we must not overinterpret past experience. Responsible management of climate risks requires sharp emissions cuts and clear-eyed research on SRM, linked with the development of shared tools for managing it. The two are not in opposition. They are not dichotomies. We are currently doing very little on either, cutting emissions or this, and we urgently need action on both. Thank you.
Thank you, Chairman Baird, and the subcommittee for inviting me today. I think I'll start by just reminding you of what solar radiation is. How about now? Thanks again. I'll start by reminding you of what solar radiation management is. Scientists tend to loosely refer to light or heat or energy as radiation. And so when we speak of solar radiation management, we really mean managing the amount of sunlight reaching the surface of the Earth. If we can reflect a little bit more sunlight back to space, then we'll cool the planet. Before jumping into some of the scientific issues, I'm going to speak just for a second on funding issues. If you look at my assessment of funding in the written testimony, you'll see that I think that the total grants from U.S. agencies today for geoengineering research amounts to about $200,000 a year. If you add in some invisible funding that comes from faculty members or scientists like myself donating their time, it might double. If you add in then foundation money, it might come to $1 million a year. If you contrast this with the kind of a program like the Apollo program to put a man on the moon of $2 billion per year, or total up all the climate research today of $1 billion per year, then you can see we're currently putting a tiny, tiny amount in. And maybe that's the right thing to do. That's really for policymakers like you to help us decide. But if you think it's important to do geoengineering research, then it would be very easy to make a big difference with a relatively small amount of money. You asked me to talk about the solar radiation management techniques known as stratospheric sulfate aerosols and cloud whitening. I've worked in both of these areas. Scientists are interested in these two ideas because we already know they play a role in the real world. We see that when volcanoes produce sulfate aerosols high in the atmosphere, that the planet cools. We see that when some ships inject aerosols as pollution into clouds, that those clouds become whiter and reflect more sunlight. Some of those clouds do, which should cool the planet a bit. We think we might be able to do the same kind of thing deliberately. In climate models, when we brighten the clouds, we see that the planet cools. When we inject an aerosol like the volcanoes do, we see that the planet cools. That's the good news, but that statement's far too simple. There are also undesirable things that happen. We see that even though we might make the average temperature of the planet about right, the rainfall patterns change some from today. And some places become warmer and some places become cooler. So there are going to be winners and losers in this geoengineering activity if we were to do it. But nevertheless, as David has said, there are reasons why we might consider doing it. We know that the models that we're using today are far too simple and incomplete. We know how to do better. There are many outstanding, unresolved, important issues that need to be addressed if one wants to understand geoengineering better. I've made some suggestions in my written testimony about ways we might use funding to strengthen the activity involving computer modeling, technology development, lab, and field research. There are a bunch of first-class research scientists and engineers in the U.S. and Europe now working for free in their spare time to think about this, but there are some things that take money to solve, and a much better job could be done if there was a funded program for geoengineering. All the work that I've suggested doing essentially comes down to focusing on two questions. Can we actually create particles in the stratosphere or whiten clouds as we assumed in our first climate studies? We need technology development and we need fundamental research to do that, to understand this. Then the second part would be, what would be the impact on climate if we did put the particles into the stratosphere or whitening clouds? This involves deployment, actually, at some level. I think I have to skip over, in the interest of time, my discussions of some of the subtleties of the ways we could focus on the cloud whitening or the stratospheric aerosols, but I'd be glad to take questions about it. You also asked me to address deployment issues. I feel very strongly we're not ready for deployment, if by deployment you mean trying to affect the climate. There are too many things that haven't been looked at yet, but there's a lot we can do with field work that'll help us understand geoengineering but won't change the climate. For the cloud whitening strategy, field and modeling studies would help us understand a critical feature of the climate system called the aerosol indirect effect, which is really critical for understanding climate change more generally as well. I don't have the time to talk to you about this now, but I'd love to address it if you ask me questions. I think that if we manage to tighten up our work to the point that we think a geoengineering strategy looks viable, it would probably require a Manhattan Project, looking at it with a much larger group of stakeholders, checking the science, searching for flaws in our initial work, and worrying about issues far beyond the scope of physical scientists. Thanks for listening to me, and I'm happy to take questions.
Chairman Baird, Mr. Inglis, members of the committee, thank you for inviting me. I'm delighted to be here. It's a great honor. I was a little bit puzzled, though, to start with, why I would think of this, what I do, air capture and mineral sequestration, as geoengineering, but then I started to, on reflection, to think, well, we have to stabilize the CO2 in the atmosphere against 30 billion tons or more in the future of CO2 emissions. That, by anybody's scale, one should consider geoengineering. And in my view, we will have to stabilize carbon dioxide in the atmosphere sooner or later. And it doesn't really matter whether we manage to do it right away or whether we fail and it takes a longer time and we stabilize at a higher level. As we reach stabilization, we have to balance out all emissions. We have to go to a net zero carbon economy. And I focus on capture and storage. These are capture and storage options because I firmly believe that one has to solve the problem directly and not just mask the symptoms. One may have to do that for a short time, but ultimately one has to solve the problem, which means managing that all the carbon which goes out is balanced against something else. That means, in turn, we need comprehensive solutions for carbon capture and storage, and I would put air capture and mineral sequestration into that larger category, and would argue that carbon capture and storage has to be more comprehensive than just power plants, and we have to have the ability to store carbon anywhere and at the requisite scale, because we have the ability to put out 1 or 2 Lake Michigans in terms of mass of CO2 over the next century, and we better find a way to put all of this, and this is where, in my view, mineral sequestration comes in as an important part. Let me begin briefly with the air capture story, and I would argue what makes this so nice is it separates the sources from the sinks. One of the side effects is you will actually get a group of players who want to solve the problem and not just get dragged in because they must solve the problem. I think that's important, but most importantly, it allows us to rely in the future on liquid fuels. These fuels could come from oil, they could come from coal, they could come ultimately from biomass or from synthetically made Fischer-Tropsch processes which started with CO2 in the first place and renewable energy. But whatever liquid fuel you had and burned in an airplane or a car will go into the atmosphere and will have to be taken back. Ultimately, CO2 capture from the air allows you to reduce CO2 levels in the air back down, and that makes it important. The basic idea of the technology is actually quite simple. You can do it in a high school experiment, and as a matter of fact, my daughter did just that. Really, the issue is cost and scaling. You have to build collectors, and what we found out, they are actually surprisingly small, and you then move them up to larger and larger scales, and what we are working on right now is an attempt to go to roughly 1 ton a day units. And I have shown you, I can show you here what we can do in the laboratory right now. This actually is sort of a synthetic pine branch, as people talk about it as CO2 capture devices. This guy is loaded with CO2 because he hasn't been in my briefcase all day, and he picked up the CO2 while we were coming down here. Ultimately, we have to get to the large scale, 1 ton a day. These units, as they are mass produced, will be like cars. You would need 10 billion to make a real dent in the CO2. 10 million of those, maybe 100 million if you wanted to solve the problem with it exclusively. But keep in mind, in order to have 10 million units running, you would need 1 million production a year, which is a tiny fraction of the world car production. Cars and light trucks add up to roughly 70 million. Ultimately, it comes down to cost. We are predicting that once it's mass produced, it will operate at about 25 cents a gallon of gasoline, and that's the price for cleaning up climate and cleaning up after yourself. Ultimately, let me say a few words about mineral sequestration. I view that as carbon storage version 2.0. It is bigger in scope. It can literally deal with all the carbon we ever have. It is definitely permanent. There is no question. It doesn't require monitoring because you did take the geological weathering cycle and you accelerated it artificially. And once you have done that, there is no way back. So you can break it into ex situ, where you mine the rock and then process it, which turns out is big, but it's no bigger than the coal mining operations we have to produce the coal, which produces the CO2. And ultimately, you have also in situ. I'm involved in a project in Iceland where we put CO2 underground for forming carbonates underground, and the nice feature there is you can come back in 25 years and say it actually is permanently stored. Monitoring beyond that time is not necessary. The challenge here, in my view, is cost. We are roughly a factor 5 times more expensive than we should be at this point, in my view, and I think that is an R&D challenge. If I look at the other sources of energy, I would argue a factor 2 is well within what can be done. So to me, air capture and mineral sequestration provide a comprehensive solution. Under that umbrella will be better specific solutions. It makes no sense to not scrub a power plant and then go after it from the air. But I believe we ultimately have the big challenge that the energy infrastructure of the year 2050 is not yet understood. And I think, therefore, I have a can-do attitude, but you can only do by doing, and you can only learn by doing, and you have to do the research to make it happen. And energy is so central to our well-being that I think we should not take the risk of not knowing what to do in 50 years from now and put a reasonable, large-scale research effort behind that. And I thank you for your attention.
Thank you, Dr. Lecter. Dr. Jackson.
Yes. Chairman Baird, Gordon, and others, thank you for your attention today. Let me begin by stating that a wealth of evidence already shows our climate is changing and is a threat to people and organisms. As a scientist and citizen of our great nation, I urge you to act quickly to reduce greenhouse gas emissions. So far today, you've heard about several approaches for geoengineering the Earth's climate. My task is to discuss biological and land-based strategies. My first take-home message is that some geoengineering on land is already feasible, including restoring or planting forests, avoiding deforestation, and using crops to store carbon in soils and reflect sunlight. Plants are one of the cheapest ways to remove carbon from our air. Several limitations in land-based approaches are worth mentioning. One is that we need to apply these strategies over millions of acres to play a meaningful role. A second is money. Private landowners will need incentives to apply geoengineering. How much will these incentives cost? And how sustained will landowner responses be? A third limitation is that geoengineering will surely alter other resources we value, including water and biodiversity. One difference for geoengineering on land is that carbon removal and sunlight reflectance both change, never just one or the other. Geoengineering also alters other factors that affect temperature. We need a new framework that includes a full radiative accounting for greenhouse gases and biophysics together. That long-term framework should include water evaporation, energy exchange, and other factors in addition to carbon dioxide and sunlight. Consider this example. Imagine providing incentives for tree planting on former croplands or pasture. This activity will remove carbon from air as the trees grow. What about the same activity viewed from the standpoint of solar radiation management? Trees tend to be darker than grasses or crops and to absorb more sunlight. The same plantation that cools the earth by removing carbon could warm it by reflecting less light. Your new plantation affects the earth's temperature in other ways too. Trees typically use more water than other plants. This increased evaporation cools land locally, loads energy into the atmosphere, and can produce clouds that absorb or reflect sunlight and produce rain. Overall, such biophysical changes can affect climate more than carbon removal does, and sometimes in a conflicting way. New research is needed on a full accounting for greenhouse gases and biophysics, particularly in climate models. Some gaps in scientific understanding include the ways that models resolve cloud cover, melt snow, supply water for plant growth, and simulate the planetary boundary layer. The fusion of real-world data and models is critical for reducing these uncertainties. Our lands do more than store carbon and protect climate. They supply water, detoxify pollutants, support life, and produce food. Geoengineering on land will alter the abundance of many things we value. We need research on its full environmental effects. In the best-case scenario, geoengineering activities can help the environment. Restoring habitats or avoiding deforestation will store carbon, slow erosion, improve water quality, and provide habitat for wildlife. In a worst-case scenario, geoengineering will harm ecosystems, such as proposals to cover deserts with reflective shields. In most cases, we will have to choose which services we value most. Returning to our plantation example, forests store more carbon than grasslands, but also use more water. Yearly stream flow often drops by half after planting, and streams can dry up completely. Which is worth more, carbon or water? The answer likely depends on whether you live in a water-rich area, as I do, or a water-poor one. Unfortunately, you can't have your cake and drink it too. A new interdisciplinary research agenda for engineering, drafted by a panel of experts, is urgently needed. This process should be open and seek input from many stakeholders. Because no federal agency has the expertise to lead geoengineering alone, a coordinated working group is the best solution. I recommend that the U.S. Global Change Research Program, comprised of 13 departments and agencies, lead this effort. In conclusion, although emitting less carbon dioxide and other greenhouse gases should remain our first priority, we do have short-term opportunities on land. In general, though, we need to study the feasibility, cost, and environmental co-effects before applying geoengineering broadly. We need to get geoengineering right as a tool of last resort. Thank you.
Thank you, gentlemen. I commend you for keeping your comments in the time period that enabled us to hear all of your initial testimony. We have about probably 7 or 8 minutes till we need to leave, and I'd like to recognize the full committee chairman, Mr. Gordon, if he... All right. Then what we'll do is we'll proceed with questions. I'll probably ask the first one, and I imagine we'll have to break after that. I think your points are well taken about that we need to prepare for this, but it's also well taken that we don't want to have this people believe, oh, hey, we don't have to do anything to reduce. And you've spoken a lot about carbon. Obviously, there are many other greenhouse gases of great concern, some much more potent in their efficacy in greenhouse and warming. The cost issue seems to me to be so prohibitive relative to all the other things we could do more promptly to reduce carbon. If you look at conservation, for example, if you look at development of alternative energies, if you look at, when you look at the CCS cost curve, and I know carbon sequestration is different than what you're talking about, but it would seem to me that your technology may be fairly more expensive than carbon capture and sequestration. Educate me. Is it or is it not more expensive, and if so, why or why not?
I think it's crucial to distinguish these two completely different kinds of things. Carbon removal is inherently expensive. We can disagree about exactly how much, but it's expensive. Putting sulfates in the aerosol is potentially so cheap that costs are irrelevant, in the same sense as when you think about security strategy, that actual cost of nuclear warheads is not a big driver in security strategy. Costs are so cheap that the richest people on the planet could perhaps afford to buy an ice age, that individual small states could act alone. So essentially, that doesn't mean you should do it, but it means that this will be a risk-to-risk decision.
How would you distribute that? Educate us on that.
Pardon?
How would you're saying it's so cheap. What is it makes it so cheap?
The underlying physical fact that it's so cheap is that a couple of grams of sulfur in the stratosphere offsets a ton of CO2 in the atmosphere, not in terms of all the environmental effects, but in terms of the crude radiative forcing. So I'm working with one of the leading contractors of high-altitude aircraft in the U.S., Aurora Flight Sciences. We're in the middle of a contract they have with us looking at the costs of doing this, and the costs are, as we thought, small. These costs
would you add it to the fuel, or would it
No, that doesn't work at all. That's in the blogosphere. No, you'd build custom aircraft that would fly at about 65,000, 75,000 feet. They would put the appropriate sulfur, whatever it is, in the atmosphere. And the costs of doing that really work out to be low enough that costs don't matter. We're talking about a cost to offset the entire effect of doubled CO2 that's of order of just billions a year. So that's 100 to 1,000 times cheaper.
When you say offset the entire effects of CO2.
Yeah. In terms of gross radiative forcing, as I've said and we've all said, it can't solve all the problems.
Only on the radiant side.
Yeah.
This would have, my guess, I may be wrong, would have no impact on ocean acidification.
Not at all.
Okay. And I think it's really important to understand that.
Absolutely. So this is inherently imperfect. It can't compensate for CO2 in the air completely, but it can provide an extraordinarily fast-acting thing. And this business of it being cheap, I think, is pretty much a fact. And this isn't necessarily a good thing. The downside is it allows unilateral action.
Mm-hmm. How long does it last up there?
The lifetimes are years.
What, years?
A couple years.
And then it precipitates out? Or
Yeah, that's correct.
no toxic side effects that we know of?
The thing we always wonder about is the unknown unknowns.
Yeah.
So if you're thinking about, say, the acidification, it's clear that's not a problem. There's several studies that showed that.
Right.
But, of course, the concern here is with so little research, there may be some unknown that comes out of left field that bites us.
There are issues that have come up in the literature, including interactions with the ozone layer, the water cycle, and things like that. And I agree with David, more research is necessary. My group, we do work on both geologic sequestration, CCS technology, and land-based. And I would say it is useful to remember that land-based strategies are much cheaper than carbon capture and storage strategies. The issue with land-based strategies is that on a 50 to 100-year time frame, the bucket's not big enough to solve this problem. So my answer would be there are some shorter-term options that we can do some good. In this, we can also do some harm. But there are relatively low-cost options that we can use to help us get started. Long-term, we need these bigger picture solutions like others here have talked about.
Dr. Lampman?
Let me break a lance for the more expensive carbon capture and storage options, which all of them are. My point, in a way, is that air capture is probably more expensive than any other capture, but not much more expensive, so they're all in the same ballpark. Yes, it's correct that it's cheaper to put some conservation in place to drive efficiency up and all of this, but consider I came from New York this morning, and I could have said it's much cheaper to walk, so maybe I should buy myself some running shoes and get going. But in the end, I broke down and said the distance is so large, I will buy myself an airplane ticket and fly down here. And so I would argue the same is true here too. We can make a difference by efficiency, by conservation, and doing all of these things. But in the end, if you want to keep the level in the atmosphere constant at any number, once you got to that number, you really have to drive emissions close to zero. And keep in mind, with the rest of the world growing, basically you have to come down by factors of 20 to 30 in order to hold things in a semblance of stability. And that requires more drastic solutions, and they in the end will cost a little more. And you are closing the carbon loop by adding another third to it.
Thank you. We are going to recess at this point. My belief is we have most likely at least an hour of votes. So we will resume the hearing at 11:30 with the indulgence of our guests and our panelists. I apologize for the interruptions, but we don't get to set that part of the schedule. Thanks. We'll see you in an hour. Thank you for your indulgence on this hour break. I will recognize Mr. Inglis in a minute. I will share with you, though, this idea of placing particles in the upper atmosphere. Are any of you familiar with the conspiracy theory known as chemtrails? Have you heard of this? Rather interesting phenomenon. I was at a town hall, and a person opined that the shape of contrails was looking different than it used to, and why was that? And I gave my best understanding of atmospheric temperature and humidity and whatnot. And the theory, which is apparently pretty prevalent on the net, is that the government is putting psychotropic drugs of some sort into the jet fuel, and that is causing a difference in appearance of jet fuel, and that is allowing them to secretly disseminate these foreign substances through the atmosphere via our commercial jet airline fleet. Thanks to Dr. Keith, I know that's true. The blogs will have your name, Dr. Keith. I'm just kidding. But it does, in a more serious note, it does highlight that if we're going to do this, we are going to have to be very clear with the public about what we're doing and how we're doing it and why we're doing it, and unintended consequences, because legitimate scientific research must not get tied up into these kind of things. Dr. Keith?
I think it's really crucial to do it in a transparent way. And one of the reasons I think we need a small government program now is to inject some transparency, because right now we've got a hodgepodge, including private money, and that increases the risk. The people are very fired up about this. I have voicemails from people who've told me I'm going to burn in a lake of fire and I don't love my kids and it's a mass murder. Oh, yeah. So
it must be on the same mailing list.
So I think that it's the only cure for that is transparency.
Mr. Inglis.
Thank you, Mr. Chairman. It strikes me that what we're talking about here is something that's very difficult to do because there's no profit to be made in it. And if you think about it, the other way of cutting off this CO2 has a real profit motive in it. And the way that you can really get things done in a free enterprise society like ours is to give people an opportunity to make money. They'll move quickly if they can make a buck. What you're talking about here, I think it just involves government expenditures, because I don't know of any customer who would buy these things. So it means that you're doing appropriations to support this with some real questions about the science of it, and B, selling people on the idea of using their tax money to spend money on something that they can't see any tangible result from. It's a little bit like putting padding in a car to avoid injuries with DUI or something. I mean, maybe what you should do is stop the people from being DUI rather than putting padding in the car. And so what I'm also aware that the committee had an opportunity to be in Greenland, and we heard about an earlier idea several decades ago of putting coal dust out on the glaciers in order to help heat up the glaciers. Gee, I'm glad we didn't do that. And we heard too, though, about the good thing of getting lead out of gasoline, and the result is a real improvement in the situation in the glaciers. So, in that sort of a picture, I mean, in one, we're going out thinking about putting out coal dust. In the other, we're just removing a noxious substance, and the result was really good. So you have to be real certain of the science, and then you got to figure out how you sell a constituency on it. And the thing I'm looking for always when dealing with climate change is some way of getting a twofer or a threefer. And this is a one-fer. I mean, you just get one thing, is CO2 out of the air. And you got a problem finding a constituency, you got real questions about the science. If you think about it, if you can incentivize people to really go after reducing emissions and make money at it, then you can create jobs, you can improve the national security of the United States, especially by breaking the addiction to Middle Eastern oil, and you can clean up the air. It's a threefer, and it's driven by profit motive. Wow, what a deal. Because, you know, this thing, if we'd done this by appropriations, we'd be dragging it behind our cars in a trailer, you know, with 2 technicians figuring out how to get an email across. But because this was profit motive, look at this incredible thing. They made $1 bazillion making these things. So that's what we're after, right? And so I realize I'm really panning the idea here, but so anybody want to defend it since I've totally panned it? But who wants to go? Dr. Ross, you should look like you want to tell.
Yeah, sure. I'm happy to respond. I guess the first thing to say is that I think probably all of us agree with you on 99% of what you said. I think the first thing to say is that the only reason that we're considering doing geoengineering, it is going to cost money that we wish we didn't have to spend, is because the consequences of not doing anything might be more costly. I guess that's the first thing. And then the second thing to just mention is that, of course, we also want to find a way of changing our energy technology so that we're not emitting the CO2 or other greenhouse gases. And the best way is to do it the way that you're talking about. We're a bit concerned that it's going to take a while, both to convert the technology to reduce or zero out emissions, and also, even if we were to do that, it's going to take a while for the planet to come to some equilibrium with respect to the emissions that we've already made and those that are coming. And there are also difficulties with respect to continuing emissions for things like transportation sectors, which were also mentioned earlier this morning. So we don't really like the idea of doing geoengineering, but we can't see any way around it. Well, we see that we may need to do geoengineering. That's all.
Yeah, I see that my time is up. I hope we have maybe, I don't know, we may come back to it, but you know, it reminds me of the Malthusian predictions too about the manure in New York City. It really undercuts, I think, our efforts to do something about climate change to have Malthusian predictions. I mean, the reality is that Henry Ford created the car and made $1 bazillion on it, and the result was we didn't have horse manure piling up to second-story levels in New York City, and so, or however it was deep it was supposed to get, and so I really think that when those of us that are out trying to say, let's take responsible action, or sort of hear the chorus of, gee, it's a Malthusian prediction, then it really undercuts our effort of trying to get people to buy into this about, say, gee, we can make a buck, we can improve the national security of the United States, and we can, if you care about it, you don't have to care about it, but if you care about it, we can clean up the air too. That's how to sell change. The other thing is, really hard to sell. I can tell you in the 4th District, South Carolina, it'd be extremely hard to sell. I yield back.
Apparently, Dr. Keith would like to speak about euphemistic Malthusian predictions, which may be a euphemism for horsepucky, but Dr. Keith?
I think the profit motive and entrepreneurialism are just fantastic, and I think it's vital that we actually talk about this in a positive way. We've solved an enormous number of pollution problems over the last 100 years. We made huge progress on cleaning up air and water, and there was a lot of innovation that came bottom up. I run a little company that's trying to innovate, and we don't think we should make that money in the long run by government appropriations. We think what we need is a clean, transparent law where government doesn't pick winners but does restrict the amount of CO2 going in the atmosphere, and we want to and intend to compete and win in that world.
Mr. Rohrabacher.
Thank you very much, Mr. Chairman. You know, I come to this, I actually waded through the snow today coming here and noticing how miserable I would be without global warming. It would be even worse. Actually, the snow we've had and the temperatures we've had in the last 9 years totally are contrary to what we were told in this committee for about 10 years. All the predictions of the people who were came here to talk us about global warming, I know they've changed it now to climate change because the climate doesn't seem to be doing what they said it would do. But in this committee, we were testimony after testimony about what was going to be happening. We're going to reach this turning point. It's going to get hotter and hotter until it would reach some point and that would really get hotter. And it's been just the opposite. We come into this hearing today, and the last month, we've heard not only the revelations that come out of these hacked communications, which indicate a lack of scientific credibility behind certain issues that have been brought up in the global warming debate, but we also have found that there was, in the IPCC report itself, that the Himalayan glaciers that were predicted, that prediction was not based on any scientific research. And just last week it was indicated that, and found out that the guesstimate on the Amazon rainforestation, the elimination of the rainforest, the Amazon had no scientific research and basis. And we also heard just recently a statement from the Russian Academy of Sciences that the information they had provided the IPCC was cherry-picked before it was put into the computer model to have an outcome that was not a scientific outcome, but an outcome that was predetermined by the people who were putting the project together. These things would cause us reason to doubt the premise which your request for the spending of billions of dollars to remediate a problem is based on. For the record, Mr. Chairman, I would like to place in the record, there are thousands of such scientists, and you know them, who disagree with this theory that your proposals are based upon, but I would like to put a list of at least 100 of those thousands of scientists who are prominent scientists who agree with the case for alarm regarding climate change is grossly exaggerated. Surface temperature changes over the past century have been episodic and modest. There's been no net global warming for over a decade. The computer models forecasting rapid temperature change abjectly fail to explain recent climate behavior. And finally, characterization of the scientific facts regarding climate change and the degree of certainty informing the scientific debate is simply incorrect. I would like to place for the record the list of 100 prominent scientists who agree with those statements.
If it doesn't exceed the requisite page limit,
well, we'll squeeze them down into a little
because that is an
into
issue.
one page, if you'd like, Mr.
If you want to submit one page, then without objection.
Otherwise, we'd be wasting all of that carbon in the paper, right?
Well, it has happened before that we have sought to do that on our side with objections.
Now
from
to the
other
questions based on some of the reading that I obviously have had on this. What percentage of the atmosphere is CO2? I have asked that question, by the way, of numerous people, and after hearing all of the various proposals about the importance of CO2, most novices think it's 10% or 20% of the atmosphere. What percentage is it?
390 parts per million.
It's It's 0.0395 something. It's less than 1/10 of 1% of the atmosphere.
And maybe it's
In
useful.
fact, it's less than 1/2 of 1/10% of the atmosphere. Is that correct?
Yeah, and maybe it's useful to think about where the knowledge that that could cause a problem came from. It came from the Air Force Geophysics Lab in the 1950s. So one thing that you lose in all the hype, and IPCC has overhyped, and all the hype on both sides, is the stability of the core science. So the original modeling that showed that, surprisingly, it is surprising, that that small amount of CO2 could have a big effect on climate, that modeling was first done accurately by the U.S. Air Force.
Yeah, most of the
And it
scientists
wasn't-
that
right, it wasn't
I only have a
politicized.
short period of time. Let's just note that the point is not accurate. There are many scientists who disagree that that small amount of CO2 has anything to do with the changes in the climate. Especially now, is it your contention that this tiny, minuscule amount, and of course mankind's investment into that is only 10 to 20% of that. 80% of it comes from natural sources. That would even makes it even more minuscule. That is a more important factor to the change in our climate than solar activity, this huge, the biggest source of power in our universe, but this little tiny thing is more important than that? Go ahead.
I would say yes, and I don't come at it as a climate scientist, as a matter of fact, and I'd be happy to stand away from this. I'm a harmless physicist when it comes to this. But Fourier understood this in 1812, and really nothing much has happened new since Arrhenius in 1900, and yes, if you were to take the CO2 out, the Earth would be very much colder than it is today. It is a simple greenhouse gas, and what we are talking about are fine details of what happens if you make small changes to that admittedly small number. Nevertheless, it's important. If you take it out, you also have no photosynthesis. Your ocean would be a hydroxide solution. So there are lots of things which make this important. Nobody argues about argon, which is comparable in content because it's inert. It doesn't do anything.
Those 100 scientists that you mention are also would not disagree with anything that Dr. Lechner just said.
Okay, but let me ask you,
let me try to.
Let me get this specifically. Has there been a time when the CO2 in this planet's history, when the CO2 level was much greater, but that we had abundant plant life, oceans that flourished with life?
Absolutely. So 50 million years ago, there was 1,000 or 2,000 parts per million CO2 in the air, several times what it is now.
Right.
And there were alligators in the high Arctic, and there's nothing wrong with that whatsoever. Okay. The problem is about pace of change. It took 10 million years for CO2 levels to come down from where they were in the Eocene, and we are planning to put them back up to that level in one human lifetime. That is 100,000 times faster. There's nothing inherently wrong with a warmer climate. But that argument is fallacious because it neglects the issue of rate of change. When things change 100,000 times faster, you have a problem.
Well, except, of course, if the Earth has several volcanoes that erupt, right? And that might do as much change as what we do in a full year or two. Isn't that right?
If you get a big enough volcano, it can have a catastrophic effect on the Earth.
So volcanic activity really has something to do with this as well. That may even override what human beings do.
It certainly will override a year or two. The point which convinced me to work on it, because I had to go through the same sort of question some 10, 15 years ago when the climate science was far less certain, and whether it's worth spending time on these issues. What convinced me is we can have a long and learned debate what precisely is the right number to stop at. But once we reach that number, we have to stop emitting. Because to a very good approximation, this is like pouring water in a cup. As long as I keep pouring, it goes up. And so we could have an argument whether 450 is the point to stop. And there are some people who are of a different opinion than I am on that.
A lot of scientists, for example, suggest that the baseline that you're using to claim that there's a temperature change going on starts in 1850. And we all know that 1850 represented the bottom of a 500-year decline in temperatures, which what they call, I think, the Little Ice Age or something. which the scientists that I'm talking about point to that and say there has not been any change, even though we have this supposed increase in CO2.
I guess it discourages me a bit, I must confess, to still be debating things like whether greenhouse gases are increasing and whether the Earth is warming. The Earth's temperature is warming. 1998, the only reason that there's some discussion about the warming slowing is that 1998 weather was off the charts in terms of warmth. It was unprecedented in terms of warmth, and it was so high that the bouncing around since then, it may have slowed a little bit. My suspicion is that in 5 years it will be back to the
So you're
same
saying
warming.
that this 1850 argument that using that as the baseline really isn't accurate because we have actually grown a lot more than what would have normally been throughout the 1,000-year, 2,000 years histories of humankind.
I'm just saying that it's not an 1850 discussion, it's a million years and longer discussion through different methods. I'm just saying that the knowledge base is quite strong. I guess I would also like to add that when we think about changing the Earth's climate, as a climate and environmental scientist, I'd also like to remind people that there are millions of other species that we share this planet with. And 50 million years ago, those species were free to migrate and move. That's no longer the case. So we have to think about human adaptation and human costs, but also the ability of the other species that we share the planet with to move in the kind of lifetime that David Keith was talking about.
Well,
and is that possible?
The CO2 argument, and I certainly agree that we have a footprint, but it's not just a carbon footprint. And thank you very much. I see my time's up. Thank you for indulging me, Mr. Chairman.
I thank the gentlemen for their responses. I want to commend you. Some of the arguments that Mr. Rohrabacher has made have been offered previously by panels of climate scientists without response, and I commend you for the response. I want to drill down a little bit on one of these issues, and Dana and I are very good friends, and we disagree on the conclusion here, but there's a premise that seems to be that if something appears to be a small quantity, that it then assumes it cannot have a large effect. My understanding is ricin in microscopic quantities can be dreadfully fatal. I take a little tiny pill each day called Lipitor, which relative to my body mass is pretty darn small, and it seems to extend my life. If I were to put a thin film of plastic over your mouth, you would die. If I hold it under the sun, it'll warm you up a lot. A thin film of plastic, which relative to the thickness of our atmosphere is far smaller than the parts per million we're talking about, and yet it could, nobody would dispute. You lay a piece of plastic on the ground, sun comes through it, things get hot. So this fundamental core argument that because CO2 is a small percentage of our total atmosphere, it cannot have dramatic effects we can illustrate countless examples in nature where apparently tiny quantities have dramatic impacts. So I think we would do well to reject that as a line of argument. But beyond that, my understanding of the recent temperature data from this year suggests this past year was a pretty warm year, in spite of the fact I think proponents of climate change make an egregious mistake when there's a tornado somewhere or a hot day somewhere and they say, oh, look, must be climate change. The opponents are guilty of the same problem. And my understanding is the pattern of temperature last year was actually a pretty warm year. Is that your understanding?
Absolutely.
And my understanding also is that the IPCC and NASA itself have looked at the solar radiation issue and largely refuted the notion that solar radiation increases. I mean, they've modeled it elsewhere, and they've said solar radiation increases are not believed to be responsible for the apparent temperature increase. Is that your understanding?
Yes.
The record showed that these four distinguished gentlemen all say yes on that. I think there's a need to, the temptation is to say, well, there's one thing or a few things that point maybe in the opposite direction or questions of data, and there's no question in my mind that if data are distorted on either side of an argument, that's as a scientist and someone who's introduced legislation to promote ethical scientific conduct, that's a problem. But a few bad examples don't seem to me to overwhelm the abundant evidence that I think you gentlemen are citing. So back to the issue at hand of geoengineering. Let's talk about solar radiation management a little bit. I want to talk about that and also about the carbon uptake. We'll start with carbon uptake, the white pine tree that you gave us. Give us some cost, both carbon costs, what's it cost to produce that in terms of carbon, and And cost to manufacture, you mentioned, I think, 25 cents a gallon?
Well, this is once you're in a mass manufacturing mode. We are still in a research phase, so we have developed this material, which is an anionic exchange resin. If it's dry, it absorbs CO2 out of the air. If it's wet, it gives it back. So around that, we built a cycle which allows us to collect the CO2, compress it, and we'll pay energy for that. So the main energy consumption is the compression. Figure that we roughly give 20% of the CO2 we collected back because some distant power plant is generating electricity in order to feed that system. So that's the order of magnitude of what you have to give back. The cost of the electricity is small and would be well within that 25 cents.
So you're able to, once that thing draws the carbon out of the air, you're able to then draw the carbon off of that.
Exactly.
Okay.
So this is like a sponge to soak it up, and then I squeeze the sponge out and then I can do with the CO2 whatever is necessary. I can put it to mineral sequestration, I can use geological sequestration, or if you just happen to want some CO2 for a fizzy drink, I can sell you that CO2 for that purpose. Clearly, I have no carbon impact if I do that. But
if we burp, we screw up the cycle.
Yeah, you would have kept the cycle going. But for a small company, again, that actually gives you the profit motive, because in the beginning, those are the markets, and quite clearly, in the beginning, I'm not down to $30 a ton of CO2. We estimate that the next round, where we go to a 1 ton a day unit, we are at about $200 a ton on the first try. But that's like your handmade first car.
How about the carbon cost of producing the material?
The carbon cost of that is nearly negligible to the total, because in a matter of a week or two, this machine will have collected its own weight in CO2 multiple times over. And roughly speaking, without doing a careful life cycle analysis, you have few times your own weight in the CO2 emitted as you were produced. Furthermore, the material is a polymer, so at the end of the day, it becomes fuel to close the cycle if it's once it got in.
And my understanding is we're getting some there was an article in Science a couple of weeks ago about we're getting some new developments in terms of molecules that may be able and catalysts that may be able to more efficiently strip carbon out as well. Is that?
Yes, there are a variety of options. We believe what we did here, we discovered actually a brand new way of doing it, and we will pursue this further and try to drive the costs down. And one of the things we can do is just make the material finer. Therefore, we use less of it, and therefore the cost is coming down. That's why I'm optimistic that mass production, I don't just have to appeal to the world's learning curves for other things where you say things get cheaper if you make more, but I can point my finger to things here and here and here. I can make it much cheaper.
And one last point on this, and I'll then recognize Mr. Inglis. My understanding is that a portion of the the energy demand would be very possible to meet it through renewable energies, particularly in off-peak times.
Certainly.
Yeah.
And
so we're not having to burn more coal, for example, to power our carbon cleansing mechanism. We could use renewables to do that.
You could certainly do that, and we actually have developed ways where we can wait with the electricity demand to when you don't need it, so that we can fit in that way. But overall, I would argue you can also get away from fossil fuels this way. And like the dream of the hydrogen economy is to use renewable energy to make hydrogen as a fuel. If I can give you CO2 and hydrogen, you can make any fuel you like with technologies which have been developed in the 1920s, Fischer-Tropsch type technologies. So it seems to me this opens the door both ways to carbon sequestration if you want to go that route, and if renewable electricity, or for that matter nuclear electricity, becomes cheap enough to make it worthwhile, you can get independent of oil by making your own synthetic fuels.
Terrific. Thank you. Mr. Inglis.
A microphone over here. So, Dr. Keith, thank you for that answer for Mr. Rohrabacher. I think it's a very helpful explanation. Because if it is a pace of 100,000 times faster, that really helps people to understand why it is that it's a problem. And that's the kind of thing that really builds our credibility as we try to address the issue. So and with Chairman Barrett, I thank you for answering the question, because quite often those questions do go, or those assertions go unchallenged, and so very cogent explanation there. It's 100,000 times faster. I think we can all understand that, gee, that's fast. Right now, I got to sort of celebrate something happening in our district that's relevant to this. Proterra, which is an electric bus company, is announcing that they are coming to Greenville, South Carolina at the Clemson University's International Center of Automotive Research, where they are going to begin building these buses. The bus has a number of advances. It's made out of balsa wood that's infused with resins that make it as strong as steel. It's got a fiberglass case on it that's very light. It's about a third shorter, but carries as many people as an average bus, city bus, because it doesn't have the big old diesel engines in the back. And it runs on 3,000 pounds of batteries, heavy batteries. It's a lot of batteries. They're quick charge and quick discharge. 6-minute charge, which means the physicists here can explain to us that means they discharge quickly too, right? But they figure that by going around from stop to stop and having an extended stop, maybe a minute and a half, you can actually recharge the battery enough to get to several more stops. And so around the city that uses such a bus, there won't be any emissions from the diesel. The electric bus goes faster than a diesel because you can go lickety-split. I drove one right up the hill here several months ago, and we beat a city bus off the line, and all you do is put the accelerator down, and that thing moves. It doesn't have the grinding of the diesel, and doesn't have the smoke coming out the back. And it's got regenerative braking, too. So when you let off the accelerator, the thing slows down as it's recapturing that energy. What an exciting thing. These people have decided that the economics work right now. And what I wish I were there now to celebrate this with them, but I did a recording yesterday to celebrate it. And what I pointed out is if we get action on climate change, those economics will look even better. So the amazing thing is that they have something that works right now. But imagine them in the catbird seat if we do actually insist on accountability and say incumbent fuels, consider all of your externalities, force a recognition of all the negative externalities, and suddenly Proterra is going to be, wow, everybody's going to be asking for one of those buses, or many of those buses. And we're going to have jobs in South Carolina. We're going to have an improved national security because we're going to be saying to the Middle East, just don't need you like we used to. And we're going to be cleaning up the air. Now, of course, that assumes a clean way of producing electricity. But if you insist there on internalizing the externals associated with the cheap coal, then we'll fix that one too. We'll be building IGCC machines in Greenville, South Carolina at General Electric, creating a lot of jobs there. We'll be creating windmills. They're building wind turbines at General Electric in Greenville. And we'll be building nuclear power plants with a whole high concentration of engineers in the upstate of South Carolina. Now, see, I've got a parochial interest in this. I want to make a lot of people very wealthy out of figuring out a way to fix this problem. And we're going to create jobs in the process. And we're going to say to the Middle East, we just don't need you as much. And we're going to clean up the air. So what an exciting thing. So I just had to celebrate this Proterra announcement, Mr. Chairman. Can I hear a cheer for Proterra?
Go Proterra.
Yeah.
Can I comment?
What I'm scared about is you driving buses.
Yeah, I shouldn't have admitted that. It's probably, I don't have a CDL. So.
May I comment briefly? Because I think that's a wonderful example. And one way or another, one of the things that we clearly need is some sort of carbon price. And the reason I think for having a carbon price down the road is that you don't pick winners and losers. In terms of technology, you let the private sector and markets drive the innovation and the energy savings and all the technologies, including perhaps things like capturing CO2 from the air. But we must have a carbon price, and we must figure out a way to do it smartly and efficiently to protect our jobs and business. But that's what we need to drive exactly the kind of innovation that you're talking about. That's fantastic.
And can I pass one on to you? How about this? Art Laffer, Ronald Reagan's economics advisor, is a neighbor of Al Gore's in Tennessee. They agree on a 15-page bill that I've introduced. It reduces payroll taxes and an equal amount shifts those taxes to emissions. So it's a revenue-neutral bill. It's also border-adjustable tax, so it's removed on exports, it's imposed on imports.
That's beautiful. Can I comment on the need for innovation?
Yeah.
I mean, private money can do great, and both Klaus and I are in a friendly way competing, and we both have private money to work on air capture. But and in the long run, prices are absolutely necessary to allow clean competition. But we also have to find ways, and government has a role. It's not easy to figure out exactly how to do it right, in incenting innovation, because we just are not putting enough energy into energy innovation. The U.S. electric power industry puts as much money into R&D as a fraction of gross sales as the pet food industry. I didn't make that number up. We've checked that number. It's a very small amount, and we need to find a way to make this economy more innovative. And private money is necessary, but we need ways for government to encourage innovation, both through specific sort of tax policies and direct funding for basic R&D. I think that's crucial.
Yeah, you know, I found that out actually visiting with a utility that's subject to Public Service Commission. They're sort of proud of the fact they didn't have an R&D department. And the reason is that they can't figure out how to pass those costs along through the PSC. And so they took it as a point of pride that they weren't charging the consumer with those. So it's a real chicken and egg kind of thing. You got to figure out how to. But if you establish a clear price and you insist on accountability, which I believe, by the way, is a very conservative concept. I mean, I'm a conservative Republican, and I'm here to tell you that if you allow people to be not accountable for what they do, belch and burn for free, well, then you get market distortions. Yeah. But if you insist on accountability, then those incumbent technologies lose to new technologies.
Let me 100% agree with you on that point. We do need some way of holding people accountable for the carbon. My view is this has to be somehow built into price, ideally as high upstream as you possibly can.
Absolutely.
And then we move on and say all these various options can compete. Your electricity-driven bus, I think, is a great idea. I'm 100% behind that. It's a little harder for my sports car to have all of those batteries in it. And so maybe the 100 times higher concentration in the liquid fuel, which could be synthetic, is another option. But let the market figure that out. And what I'm driving towards is that we shouldn't close options off. Air capture is an option. Electricity is another option. Yeah. Which of the two will win? I tell my students, I can't tell you today. Yeah. The markets will have to figure this out, and it's too close to call with 50 years ahead trying to work this out. But we do need the market to sort this out.
Thanks, Mr. Inglis. I want to ask two quick more questions, and then if Mr. Inglis, and if we may finish at that point. It seems to me that the most basic form of you folks have been very informative here, and it makes sense to me that we ought to look at this much more than we are. The most basic form of geoengineering that I've heard about is paint your roof white, which actually can very little cost and dramatic benefit. Is that your understanding, that if we could move, towards lighter colored shingles, and in fact I understand people are making photovoltaic shingles now, what are your thoughts on that?
Huge local benefits, so huge potential benefits in
this
reducing
city, for
cooling
example,
loads and city level loads. But we looked at that in the context of the UK Royal Society Geoengineering report, and I think it's pretty clear that as a method of changing the global climate, it's both too small to matter and actually not cheap. But locally, to help cities and to help reduce cooling loads, it can be very effective.
Right, and dramatic, not dramatic, but noticeable impact on cooling loads especially.
If I could respond to it, it doesn't have much effect on the brightness of the planet, but it does have a big effect on the energy.
So we're not going to change planetary albedo by painting our roofs white, but the city of Washington, D.C. could substantially reduce its load and livability. That means less air conditioning. That means less carbon burden for the air conditioning.
Yes, absolutely.
And in terms of research dollars, one of my concerns, I was just at the World Economic Forum, and there was a lot of discussion about CCS and carbon capture and sequestration. We're building an enormous base infrastructure right now. We already have one in coal, but we're building it, China particularly and other nations are continuing to expand on the bet, basically, that we're going to have some form of CCS that's economically viable. And the projections we've heard in this committee previously suggest there's a real question about that. And on top of that, if you're adding more carbon, the efficacy of reducing the existing carbon, and you're just trying to keep up with an ever fleeing target, it would seem to me that we would be much better to do a couple of things, to invest large investment right away in conservation, because that's your quickest and most immediate return on investment. Then put money into disruptive technologies like distributed photovoltaics or wind or other, or like Dan Nocera's doing in MIT, some form of better hydrogen and fuel cell, rather than letting the money go into these big coal plants that then just commit us to a coal path and then make all your clever devices, Dr. Lackner, not reducing down to 350, which we're already above 350 parts per million, but trying to keep up with this fleeting target. What are your thoughts on this? If we throw so much money into into new coal capacity versus, what does that do to us?
I think we should do what you just said, because it's important to go after the low-hanging fruit. But I come back to where I started. Particularly if you talk about other countries getting into it, you're talking in the end about a world of 10 billion people who strives to have a style of living we take for granted, and I think we should do everything we can to allow that to happen. Now you need an awful lot of energy, probably 4 or 5 times as much energy as we're using today. So I started to ask myself the question, where could all that energy possibly come from? And there are very few resources which are big enough to do that. I would argue one of them is solar energy. There's no question we have enough sunshine, and we should have a big, big program there. Secondly, I think nuclear energy, with all its problems, is a second one which is actually large enough to solve this problem and can play as a truly big player. Thirdly, you have fossil fuels. We may be running out of oil. We are not so likely running out of gas, and we certainly are not running out of coal in the foreseeable future. So in my view, you have some 200 years there to keep banking on that fuel, provided you have carbon capture and storage in place. So that has to be part of the bundle, because otherwise you simply couldn't dare to use all of this carbon. So in my view, standing back a little, there are 3 major resources, and we better place 3 big bets, making sure that at least one of them pays out. Now, I'm optimistic that each one of the 3 has a fair chance of getting through. But if we were to fail on all 3, we would have an energy crisis of unprecedented proportion, no matter how well we do in terms of conservation, improved efficiency. Those can help, but they cannot solve the problem. And I would argue the other energy sources we are talking about on that scale are too small. So those 3 I would view as in a special category, and we have to pay attention that they work. And then a market has to figure out whether it's 30-30-40 or whether it is one winner takes all in 50 years. I cannot predict that. But we better not close the door on any one of those.
May I add wind to that list as well? I think, so I agree with all of that. I can't pass up an opportunity to say thank you for emphasizing the need for conservation and renewables. Those are things that we can do now. When we're discussing geoengineering, we're talking about things at best 10, 20 years farther in advance, perhaps and hopefully never if we don't get to that point. But it's increasingly likely that we will get to it because of the increase in fossil fuels. So anything that we can do now, and there are many things we can do now to improve efficiency and provide incentives for renewables like wind and solar, I wholeheartedly support. And a market is the best way to do that. On top of that, though, when we build a coal plant, that coal plant's on the ground for 40 or 50 years, perhaps. So I do believe, as strongly as I feel about conservation and renewables, that we have to pursue at least economic and feasibility analyses of CCS. Perhaps carbon capture and storage directly from the atmosphere is another example. It's not an either-or situation. In my view, these are backup plans because we're not doing the job we should be doing as quickly as we should be doing it.
CCS has become a bit of an orphan child, so I think we should do everything we can to stop building any new coal plants without CCS. I'd be happy to see a ban. But I think it's tempting to say, and I agree with very much with the idea that solar, nuclear, and coal with capture are the big players in the long run, wind to a less extent. But I think it's important to be clear about the politics of CCS right now. So it's an orphan child. The NGOs, at best, are lukewarm. And the coal companies' preferred strategy in many ways would be to have it be R&D forever so they don't get regulated. And so it's sort of caught in between the two. Yet, nevertheless, it looks to those of us who spend a lot of time on it that you could actually build gigawatt-scale power using coal with capture today. And the cost of doing that would be much lower than, say, the cost of solar today, much meaning factors of several.
There are, with respect, there's substantial dispute of that.
I actually don't know any serious dispute. I've served on the IPCC panels.
About the cost the cost curve?
Here's a simple way to say it. The feed-in tariffs that we need to make solar happen are of order 30, 40 plus cents a kilowatt hour in places we're really doing it. I helped to get in Alberta, where I come from, one of the first, probably what will be the first megaton a year scale plant happen. I helped to recommend and was involved in the contracting for that. Those costs are substantially lower. So TransAlta will build Alstom's technology. They'll be done in 3 years for a 1 million ton a year effort, and that's base load power. It's ugly. Nobody likes it. It's not sexy. It's something that sort of nobody wants, but it is something you can actually do and provides low CO2 electricity at a cost that's reasonable. And I think we'd be very foolish to throw it out.
I will not stipulate to that, having heard Mr. Heller's comments in Davos last week. And
I'm not sure I agree completely with that either.
It is indeed a complicated story, but if you look back to the sulfur discussions, the sulfur dioxide discussions in the 80s, the estimates right before it happened were typically an order of magnitude larger. I think in the absence of economic incentives, prices tend to escalate. And so I would argue there is a complicated story. If you want my intuitive feeling, and it's no more than that, these costs will come down to somewhere around $30 a ton of CO2 in power plants.
I also wanted to say that it's an orphan child. The energy bill that passed the House had $100 billion over time in CCS. That is a hell of an orphan. You were saying, Dr. Rash, the best you could get was $1 billion. Was it even $1 billion or was it $1 million?
$1 billion for climate, and we were currently at $1 million per year for geoengineering.
$1 million for geoengineering. So we're order of magnitude, 3 orders of magnitude. 3 orders of magnitude. Five orders, yeah, right. 5 orders of magnitude. And so I don't think it's an orphan child by any means, and I think it's an orphan child that's a darn expensive child when you're putting $100 billion. And so if you're going to say that yes, the cost of CCS may come down, well, what if you put $100 billion on alternative technologies? And one last note on this, and then I'll yield to Mr. Inglis. The coal cost is not just the carbon cost. 5,000 miners a year die in China. It's a centralized system with a very inefficient transmission. We lose a tremendous amount of power across the transmission. There are all the other eminent domain issues, whether it's pipelines to transport the carbon or transporting the energy through those lines. I'm very much personally much more of a distributed energy person with backups of the kind of thing you're doing. But I worry greatly about the big investment in coal, and $100 billion is a lot of darn money that could go somewhere else. Mr. Inglis?
I pulled it out. I pulled the plug. Just briefly, I don't know, Dr. Rouse, whether you've referenced $1 billion per year in climate research. Our numbers show it's $2.5 billion.
I tried to cite the location that I used to assess that, but I could be off by that, by a factor of 2.
Our sources.
You can also correct me on if I'm not looking at the right numbers. I'm glad to be educated on that as well.
But it's which is a fair amount of money. The thing I just go back to is that what we see in this committee quite often is some things that will work. We know they work. For example, wave energy works. It's obviously got to work. I mean, you can do it in all kinds of ways. The question is whether it works economically. And the way to get things, I believe a basic role of our government is to do basic research. I mean, it's an important function that we do. But then once it gets into the applied range, what you're looking for is just economics at work. And when these economics start working, things happen quickly. So, the internet came from a defense research that then saw real opportunities in the private sector, and wow, what an opportunity it was. By the way, I might point out this 15-page bill, do another commercial for it. It starts out at $15 a ton, gets to $100 a ton over 30 years. And but we can go steeper than that if you want to. Just give me a tax cut somewhere else. In other words, how low you want to go on taxes, how low you want to go on reducing those FICA taxes. Well, I'll go all the way down. And then we'll shift them on to something else. And so the idea of the curve is it gives a period of time for innovation, and then it starts going more steeply. But the process is, I just want to point out, the bill, as I say, that Art Laffer, Ronald Reagan's economics advisor, and Al Gore both support, is 15 pages compared to the 1,200-page cap-and-trade monstrosity. And so, which is a tax increase, decimates American manufacturing, and is a trading scheme that Wall Street brokers would blush about. And so we got to find something simpler and something that people can say, I see, we're just going to, give me money in my pocket so I can go buy these wonderful shingles that Chairman Baird was just talking about. We're getting ready to need to replace shingles on our house in several years. I want to replace them with solar collecting shingles. But I need some money in my pocket, so reduce my FICA taxes, and I got some money now to innovate. If you just give me a tax, I'm stuck. I don't have money to innovate. And the cap-and-trade folks who go around and say, no, it's not going to increase energy cost, well, then why do it? I mean, it's disingenuous. Of course it's going to increase energy costs. Otherwise, you wouldn't be doing it. But in my case, what I'm saying is I got money for you in your pocket. Then we're going to increase energy costs. But I admit that energy costs will go up under what Art Laffer, Al Gore, and I are talking about. But we got a tax cut. If Art Laffer's on the scene, you can be assured that it starts with a tax cut. And so you got money in your pocket. It's sort of like the fair tax. It's just a small fair tax. It's a one sector fair tax. Anyway, enough of my commercial, Mr. Chairman. Thank you for the opportunity.
I'm actually a supporter of the commercial product. So I want to thank our witnesses. We could go on for a great length here, but you've been very generous with your time and your expertise, and it's been most informative to us. As customary, how long do we keep the record open? Hang on. I've got some closing remarks I'm supposed to make. The record will remain open for 2 weeks for additional statements for the members and for answers to any follow-up questions the committee may ask of the witnesses. And with that, the witnesses are excused with our great gratitude and appreciation for your work. Thank you.
Thank you.